So, what kinds of written questions might you expect? I guarantee there's going to be a question where you're in orbit. Maybe around the Earth. I might, for giggles, just make it around the moon. There will be one question where we're around the moon, because I dream, Zach, of space travel. Make sure you use mass of the moon and radius of the moon from your formula sheet. Don't use radius and mass of the Earth out of habit. Anyways, there will be one question involving orbits. In orbits, there are four things: orbital radius, orbital speed, orbital period, and if you know the orbital radius, you also know the orbital altitude. Subtract the radius of the planet. If I give you any one of those, you can find the other three. And there will be something like, I don't know if I'll have you find all three, but at least two of them. Yeah.
Stuff like a lot of things orbiting the moon.
Orbiting the moon? Very little. We've got a few probes right now, I think, but I doubt that it's even in double digits. The Apollo command modules and such, those are the lunar landers, the ones that you see them land and then take back off. Those were deliberately detonated. They were crashed into the moon deliberately, because they left seismometers on the moon, and they wanted to see if they could detect the impact, and also if the waves coming through would tell them anything about the strata of the moon. So yeah, we don't have much orbiting the moon right now. Hopefully in your lifetime, that would be cool. So number one, key phrase is orbit. So because we're in orbit, I can say gravity is what's pulling me in a circle. I can say big G, big M, little m over r squared equals little m. And because they talked about or mentioned speed v squared over r. I don't have to cancel out the little m, but I usually choose to. In fact, this one here, we also noticed one of the r's canceled. The r won't always cancel, but in this version it does. And we end up with orbital speed equaling the square root of big G, big M over r. It's going to be the square root of big G, 5.98 times 10 to the 24th, all over 8.1 times 10 to the 8th. Do I need to add the radius of the Earth to that? No. When would I, if it said instead of orbital radius, height or altitude? Then they've measured from the surface of the Earth outwards. This says orbital radius, so I can just use 8.1 times 10 to the 8th. I don't know what the answer is. Orbital speeds are usually in the thousands or in the hundreds. 8.1 times 10 to the 8th. The Earth's radius is 10 to the 6th. So this is 2 powers of 10 bigger. This is several hundred times the Earth's radius out there. It's probably going to be a smaller orbital speed. I won't be shocked if it might even be in the hundreds. But let's find out. Oh, yeah, 701? Is that right? Which is low. Why don't we do that, Mr. Duke? That takes so little kinetic energy. Yeah, but it takes a lot of potential energy to get it out that far. And it's way more potential energy to get it out that far than to keep it out that far. 701 meters per second. If you got that 2 out of 2, otherwise I would probably give you a half mark if I saw gravity is what's pulling me in a circle. Half mark for getting the V by itself. Half mark for the numbers, and a half mark for the answer. What's the kinetic energy of this satellite? There's 2 ways I can do this. We did notice a pattern. We did find that kinetic energy was equal to half of big G, big M, little m over r. It's equal to positive half of the potential. And if I hadn't done this question already, if I didn't have V sitting on my calculator, I'm lazy. I would choose to do it that way, but you can survive just fine without it, which page is why I said you didn't have to memorize that little trivial fact. It was convenient. I would use a half little m V squared. It's going to be 0.5 little m 2500 answer button squared. 0.5 times 2500 times answer button squared. And I get, you get 6.16 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. Is that right? Or people? Yeah, 6.16 times 10 to the 8th. But again, just to show you that that little shortcut works, if I go 0.5 times big G times mass of the Earth times mass of the satellite. Oh, got a typo, Mr. Dewick. Divided by radius, 8.1 times 10 to the 8th. Got another typo, Mr. Dewick. Make sure there are no typos. A half of the potential energy, but positive. Yep, same answer all the way to all the sig figs. Which one's shorter? Depends on which approach I've gone so far. Satellite orbits the Earth with an orbital period. Orbits, orbits, orbits. They want orbital radius. Gravity is what's pulling me in a circle. Big G, big M, little m over r squared equals m 4 pi squared r over t squared. Does an r cancel here? No. In fact, I'm going to get an r cubed. Little m cancels. In fact, I think I'm going to get r cubed equals, because stuff moves diagonally, big G, big M over t squared divided by 4 pi squared. How does that help me? How the heck do I get rid of a cubed? Oh, cube root. I get to use my cube root button? That's always a happy day. So it's going to end up being the cube root of big G. Are we Earth? Yep, 5.98 times 10 to the 24th. Period, 2.4 times 10 to the 4th squared. All over 4 pi squared. Big G, 6.67 times 10 to the negative 11 times 5.98 times 10 to the 24th times 2.4 times 10 to the 4th squared divided by bracket 4 pi squared. What? Cube root. Cube root. On my calculator, it's math, option 4, cube root, answer button. Do you all get 1.80 times 10 to the 1, 2, 3, 4, 5, 6, 7? Is that right? People nodding? 1.80 times 10 to the 7th? Meters. If you got that, 2 out of 2. Owen, is that right? Okay. I'm sensing body language like maybe I made a mistake, but I'm good. If you got that, 2 out of 2. Otherwise, just like before, I'd probably give you a half mark if I saw that. Half mark for getting the R by itself, half mark for the numbers, and a half mark for the answer. What is the gravitational potential energy of this satellite relative to 0 at infinity? What does relative to 0 at infinity mean? It's saying, don't you dare use MGH. Use the cosmic one. What's the cosmic one? Negative. Big G, big M, little m over R. Did this ask me how much work? No? So this is not a change in. I'm not going to go final minus initial. This is going to be straight plug and chug. It's going to be negative big G 5.98 times 10 to the 24th, 1200, all divided by, I guess my answer button's going to go right there. You know what I'm actually going to do? If I backspace twice on my calculator, I can bring up 2 lines ago, which has big G, big M, so that's a little less typing, and then I can just keep typing from there, times 1200 divided by answer button. I think I'd do that, because why not? Is it r squared? Nope. Oh, it is negative, Mr. Duick, so I guess technically I should put the negative in front, although I probably could have just remembered to add that afterwards. Oh, put 2 times signs. Do you get negative 2.66 times 10 to the 10th? Yep. Before you turn the page, or if you change the page, that's okay. Negative 2.66 times 10 to the 10th joules. What if they wanted me to know the kinetic energy? Positive 1.33 times 10 to the 10th. Was it a part C? No, I didn't. Okay. Right? Divide by 2. Make that positive. That's the kinetic energy. Oh, what's the total energy? That number. Negative 1.33 times 10 to the 10th joules. That's the potential plus the kinetic at that location. It's a nice shortcut, but you can survive without it. For 3 marks. Really, Mr. Duick? I guess I would do 1 whole mark for that, 1 mark for that, 1 mark for that, I guess. I don't know why I made that worth 3 marks. Ooh. What's this asking me to find? How much work? That's going to be change in potential plus change in kinetic. Oh, wait. Are we in a stable orbit? Does this question say orbit anywhere? In fact, this question says lifted. You know what? I think I can say that we're starting and ending at rest. We're just asking how much rocket fuel, how much energy, how much work to just get it to the right height, to get it to its right location. Then if we wanted to keep it in orbit, we would need to give it some more kinetic energy as well to get it moving. But okay. Page, what's changing anything? And it's a surprisingly tough phrase to say. I botch it all the time too. Minus final, final minus initial. So if I hear you correctly, you're telling me it's going to be negative big G, big M, little m over R final minus negative big G, big M, little m over R initial. There's another word I noticed, Page. This one here, altitude. I'll have to add R to that, which makes sense because if that was the radius, we'd be inside the Earth because the Earth is something times 10 to the 6th. If you're 10 to the 5th, you're underground. So I'm good with that. Okay, this is where I'm going to use those ditto marks. I'm going to write out the first one, negative big G, mass of the Earth, 6450, divided by, I guess it's going to be 4.6 times 10 to the 5th plus 6.38 times 10 to the 6th. Minus minus is a plus, same thing, times same thing, times same thing, divided by radius of the Earth. Oh, how come I didn't cancel out little m's here? Isn't there an m in everything? What isn't there an m in? No m in work. Of course it shouldn't cancel because it should take more rocket fuel to put a bigger satellite up there. Alrighty. Mason, I'm going to do these one term, one fraction at a time. Negative 6.67 times 10 to the negative 11 times 5.98 times 10 to the 24th. I got a minus sign there. I meant to hit a times sign there, Mr. Duick. Times 6450 divided by bracket 4.6 scientific notation 5 plus 6.38 scientific notation 6. For the first term, you get negative 3.7612 times 10 to the 11th. Negative 3. What did I say? 7612. And then plus. Now I should be able to backspace and edit. I delete the minus sign. And I think in the bottom, I just need to delete the 4, the point, the 6, the times the 10 to the 5th. And the plus sign probably, so I don't get an error. For the second term, I get positive 4.0324 times 10 to the 11th. 4.0324 times 10 to the 11th. And now I'm going to add these together. Negative 3.7612 times 10 to the 11th plus answer button. I will get a positive answer because it does take work to put something up there. I get 2.71 times 10 to the 10th. Is that right, folks? People nodding? If you got that, 4 out of 4. Otherwise, I would probably do something like this. 1 mark if I saw that. 1 mark if I saw that. 1 mark, half mark for each of those. And then 1 mark for the answer. Is that it? That's it. If you can give yourself a lovely score, please, out of 13. And if you need to come lawyer with me, now is the time.
Mr. Dewey.
Yeah.
Should number 1A be 702?
Shouldn't 1A be 702? You're going to wait till the very end of my video to correct me, are you?
Yeah.
Let's go find that. I bet you I still have it here somewhere. Oh, heck, let's just retype it. It's going to be faster. 6.67 times 10 to the negative 11 times 5.98 times 10 to the 24th divided by 8.1 times 10 to the 8th. Check for typos. That looks good. And then square root of that, Mr. Dewick? Square root. Answer button. Yeah, it should be 702. Fine. There you go. Someone phoning me during school time? Oh no, they're doing an emergency alert. Okay. Fine.